Hey friends, this is 2-3. Do you understand conditionals and biconditionals? Now, once I made Tutu's video and uploaded it and was good to go, I realized I said the word conditional a lot instead of conjecture. I'm making both videos for logic and geometry, so the C words were kind of confused in my mouth. Hopefully you understood what I meant. Because a conditional and a conjecture are two different things. A conjecture is something you say, and we can either prove it true or not true, right? Just like a statement. It's just another word for a statement. But a conditional statement, however, is a statement in the form of if then. Okay? We put that little arrow in between, which is read P implies Q. P is the hypothesis and Q is the conclusion. So let's look at example number 1. Write each statement in if then form. I'm just going to say it because writing on these videos is atrocious. A, there are no clouds in the sky, so it is not raining. So sometimes we need to rewrite it, taking words out, maybe even kind of mixing up phrases. But we've got our P, which is there are no clouds in the sky, and our Q is it is not raining. So to make it an if-then statement, it would say, if there are no clouds in the sky, then it is not raining. Example B is school will be canceled when a blizzard hits. Now this one we kind of have to switch around our phrases. Our P is going to be a blizzard hits. Okay, so that's going to be the if part. And the conclusion to that would be it is not raining. So the hypothesis is if a blizzard hits, I said it is not raining. The hypothesis is if a blizzard hits, then school will be canceled. That's our conclusion. All right. A triangle has 3 sides. This one we can go straight through it. If a figure is a triangle, then it has 3 sides. So sometimes we'll flip-flop our statements. But remember, think hypothesis and conclusion. And think back to your science classes. Okay. All right. So let's look at this next little part. The truth table for conditionals indicates the only way a conditional can be false is if the hypothesis is true and the conclusion is false. Now I'm going to show you, I think I have a video on this one that I'm going to show you tomorrow. It does make quite not a whole lot of sense why things can be false and false, but the entire statement can be true, or the entire conditional can be true. So we're going to watch a video on that tomorrow, and I understand it can be confusing. So if you're confused as I talk through this, just hold on. Here we go. If we have a truth table and we label our P's and Q's, we've got P is true, true, false, false, and Q is true, false, true, false. The only way it's going to be false is if the hypothesis is true and the conclusion is false. Okay? Let's look at the example. Coach Jones promises his players, if you win the championship game, then I will buy you a steak dinner. Determine the truth table value of the statement in each case. The coach bought the team a steak dinner after they won the championship. All right, so the hypothesis was true and the conclusion was true. Okay, therefore our entire conditional is true. Now the second statement in B, the coach did not buy dinner after the team won the championship. Boo, coach, we won. You said you'd buy us dinner, but you didn't. You told a fib, you were false. The hypothesis was met, but the conclusion was not satisfied. C, the coach bought the team a steak dinner after they lost the championship. He still bought them steak, but they lost the game. So it's true, the hypothesis was not met, so the coach had no obligation to buy them steak. But he did it anyway because he was a nice guy. So therefore, it is a true conditional. And D, the coach did not buy dinner after the team lost the championship. True, the hypothesis was not met, so coach was not obligated to buy steak. No steak for losers. Okay, we'll talk about that more in class tomorrow. It can get kind of confusing. I agree. Okay, friends, so here's a few definitions. I noticed I typed them wrong. They are correct on your notes, but once I loaded them into the show me or into the explain everything, it kind of gives me it's a pain to get it reloaded. So I just rewrote it. Converse, when we take the converse of a conditional, we basically flip-flop the hypothesis and the conclusion. So the converse of if P then Q is if Q then P. The inverse has us negating both the hypothesis and the conclusion. So the inverse of if P then Q is if not P, then not Q. And the contrapositive is flip-flopping and negating. So the contrapositive of if P then Q is if not Q, then not P. So let's look at this in an example right here. Write the converse, inverse, and contrapositive of the following conditional. If the measure of an angle is 135 degrees, then the angle is obtuse. So the first thing I'm going to do is I'm going to do my P's and Q's. Oops, I need my pen. So the P would be measure of an angle is 135 degrees. And my Q would be angle is obtuse. And then we're going to determine whether each statement is true or false. So the converse would mean flip-flopping them. If an angle is obtuse, then the measure of the angle is 135 degrees. Well, that's false. Just because it's obtuse doesn't mean it's exactly 135 degrees. The inverse means we're going to not P and not Q. So if the measure of an angle is not 135 degrees, then the angle is not obtuse. Well, again, that's false. If it's not 135 degrees, maybe it's 136 degrees. It's still obtuse. Last but not least, the contrapositive. If an angle is not obtuse, then its measure is not 135 degrees. This is the only one that gives us a true result. Okay? Because if it's not obtuse, then it's not going to be 135 degrees. All right. Definitions, a couple more definitions, and then we have a theorem. Or one more definition and then a theorem. A biconditional is a conjunction of the form if P then Q and if Q then P. You will hear me say if and only if, or IFF. Okay, so P is true. P happens if and only if Q happens. Okay. The contrapositive rule, this is a theorem, a conditional is equivalent to its contrapositive. And we're going to talk about this a little bit more in class tomorrow. All right, let's look at example number 4. Write the following biconditional as a conjunction of two conditionals. Coplanar lines do not intersect if and only if they are parallel. So we can split this into a P and a Q. So let's look at this. This will be our P. This will be our Q. And remember what we said up here, that biconditionals are written in the form if P then Q and if Q then P. Okay, so if we say it the way I kind of wrote it, watch my thinking here. If coplanar lines do not intersect, then they are parallel. And if two lines are parallel, then they do not intersect. Okay, that's how we would write that biconditional. If coplanar lines do not intersect, then they are parallel. And if the lines are parallel, then they are coplanar and do not intersect. Okay? All right, so here's our biconditional truth table. Again, we can talk more about this in class tomorrow, but just take a moment, pause the video, and look through the why it works, okay? The why of this truth table. Because remember, for the statement to be true, both of these need to be true. See, we've got a true yielding a true yielding another true. These do not yield true statements because one of them is false. All right. The equivalent disjunction theorem says the conditional P then Q is logically equivalent to the disjunction not P or Q. And we're going to look at that truth table right down here. Again, we're going to talk about this more in class tomorrow, but please take a moment to just look at why this works. We've kind of gone through this truth table. We've done our if P then Q. Remember, the only time it's false is if we get a false right there as the conclusion with a true hypothesis. Then we look at the not P or Q. And then we can look at the biconditional if and only if. We're going to investigate this quite a bit more tomorrow in class. So just take a moment, look through this table, try to see what's happening within this table with each column, and then bring questions tomorrow if you have them. Let's look at our last example for this one. Change the following conditional to an equivalent disjunction. If a child disobeys, then he will be corrected. So this is our P. Oh, there we go. This is our P, and this is our Q. Again, remember, we're looking to change it to an equivalent disjunction. So we're looking to change it to not P or Q. So not P. If a child obeys, instead of the word disobeys, if a child obeys, okay, a child obeys or he will be corrected. A child obeys or he will be corrected. All right, we'll talk about this more tomorrow. Again, I have another little video. Logic can sometimes be confusing, especially in the grammar portions, okay? Tomorrow we're going to look through 1 through 23 odd. You've got your TRF figured out. I'm sure there's going to be some questions tomorrow. That is okay.